right. So, hello everyone. My name is Nitin. Today, I will be talking about a case study on machine learning in healthcare. So, I guess I have interacted with a few of you as a mentor. Now it's more of like we'll be talking about healthcare and how machine learning is implemented in healthcare. Okay. I'll be talking about what exactly machine learning in healthcare is. And then we'll be kind of getting into detail of one of the case studies. Okay. So as you can see here, see my slides, and I want to make it very engaging. So please feel free to, I'm not here to kind of discuss any concept as such, or it's more of a very simple. I want to keep it very simple, wherein we are talking about a use case and we are talking about a domain. So I hope you guys kind of try to understand and make it interactive enough. I would love to hear from you guys what exactly do you think when it comes to like healthcare, and I'm sure you would have used many of these like certain use cases, like there are quite a few out there, open source data sets as well. So maybe if you have, well and good. If not, then definitely you should go ahead and try something on the healthcare side as well. So just to give you a brief background about myself. So I don't have a slide as such, but yeah, my name is Nitin Singh. I have been working since around uh, 8 to 9 years or so. And I've worked for Amazon and then Deloitte. And since last 4 to 5 years, I've been working for a hospital chain, doing some real world healthcare AI for a hospital chain. They have around 50 odd hospitals in US called Prime Healthcare. Okay. So and now these points here, you might not find them on the net. These are something I kind of have understood from our chief medical officer based out of US. So as you see, the first point, implementation of EHR, electronic health records, it started around 2010. And this I'm talking with respect to US because they are the drivers of most of the things. So yeah, once EHR is nothing but a system wherein like all the electronic healthcare records is being captured digitally. So like suppose we have for Facebook or for any of the other digital analytics, we have their own mm, some sort of a digital database like an Adobe or Google AdWords. So something like that. You can kind of think it is on a very similar lines, but a lot more complicated as compared to digital marketing and like just digital data as such. So EHR, it was been like it started in around 2010, and hospitals and healthcare providers understood the importance of capturing the data then. So overall, if you see the advancement of AI in healthcare is it kind of like happens right at the end of as compared to all other domains. So it's pretty easy to do it on a finance related data or a finance related sector. The risk and most of these things are very less. You can say the implementation side, the risk, the cost, most of these things are pretty less in terms of finance or retail. So suppose like just to give you an example, you might have done these loan prediction sort of a use case, right, where trying to predict if the person is qualified to get a loan or no. So in that case, what happens is, who is the end user of it? The end user is nothing but some person, maybe an agent of that particular bank, and he or maybe someone else at the background trying to check and analyze things. But in healthcare, that's not the case. The healthcare, the user is a doctor, a renowned, maybe could be a renowned physician or a well-educated person, and you're kind of trying to challenge that person with your AI insights. So to adopt in healthcare, it's really very I would say difficult and not that easy. And that is the reason why still, I mean, even during current period, a lot of big companies like Amazon, um, IBM Watson, Google, they are still struggling to get their products into hospitals and try to implement them into hospitals. So yeah, I hope with this you have got a brief background about what exactly machine learning in healthcare is. So I would like to pause for a few seconds. Any questions so far? Anyone? Anyone who has worked on healthcare data or something? All right. Okay. All right. So let's move ahead. I am pretty much audible, right? I hope there is no internet disturbance or something.
Yeah.
Okay, cool. All right. So let's move ahead. So overall, machine learning in healthcare, it kind of comprises of, again, all these three things, what we see in a typical uh, ML problem: computer vision, NLP, and tabular-based data. So the use cases of computer vision is again into medical imaging and nuclear medicines as well, more related to genome analysis and sequence analysis. NLP, this is vastly being used these days, um, especially when we are talking about like physician notes or nurse notes, any other comments coming from claims or denial annotations, things like that. So there is a lot of text data out there to create meaning out of it. And next is tabular based data. So tabular based data, again, like some of the use cases being prediction of length of stay, readmissions of a patient, early detection of diseases. So all three have their own importance and space and implementation method. Maybe companies, and there are a lot of startups who are individually working on three different segments altogether. Like very few who have entered in healthcare and are working on all three subjects together. I have not seen any such company. They are kind of going very precise. Few are only working in, say, radiology, more related to cancer detection, brain tumor, those things. Few are just working on NLP side. Again, the same use cases here, and a few are working completely on the tabular side as well. So this is I'm trying to tell about the market, like what sort of market these use cases have. So yeah, I mean, um, I hope you guys are able to understand the importance. Okay, let's move to the next slide. All right, so today we'll be talking about sepsis. So just a moment. So sepsis is a life-threatening in disease. It comes into the body in the form of an infection, and that leads to organ failure or death. Um, I'm assuming that you guys might not know about sepsis much, but this is a type of a problem or an infection happening to patients inside hospital, and there is lot of high rate of mortality, and plus there is good amount of economic loss to US healthcare and to hospitals inside US. I mean, overall US healthcare economy, and also like providers, basically the hospitals as well. So this is now why I'm trying to put this across here is because um, I would say 4 years ago, my company wanted me to work on this problem of early detection of sepsis. So there was not a lot of content out there on the net, but then gradually I got to understand that there are I mean, this is a significant problem, and there are startups individually working on these problems. They are kind of developing certain maybe models or packages to plug that into hospital systems. So sepsis in itself is a very big problem. Um, so and now for the next 2 to 3 slides, we will be talking about more about sepsis only. Okay. All right. So early detection of sepsis. So what is sepsis? It's the body's over response to an infection. It's a condition often associated with pathogenic microorganisms in the bloodstream, and the blood's response to their presence. So this is more of like a very technical definition. Maybe a clinician or someone having this particular background of uh, biology would be able to understand this better. But for us, what how we as a data scientist see sepsis is the problem statement, the end goal, and the implementation benefit to hospital. So many a times, if suppose you move to, like, you go on to work and you're being asked to do certain problem, it's very important to understand what the problem is, how exactly your problem, I mean, by you trying to solve that problem would actually help the business. That is very important. So problem statement here was to create a model that predicts patient is likely to get into sepsis within certain time interval from his or her admission. Okay. So basically we are trying to predict well in advance that a person will move into sepsis. It's I mean, I don't want to relate. Maybe it might be a bad sort of a relation with COVID, but I kind of see it as a certain case wherein you are inside the hospital and you have come for a different um, like problem altogether. So maybe you are at the hospital to treat for a hand injury or something, maybe a fracture, and staying within the hospital, you then, due to certain infection or maybe due to certain um, not good care, um, you develop sepsis inside the hospital itself, being treated for some other disease or being brought into the hospital for some other disease. So uh, and I hope you guys are able to relate, because this is something happening with with unfortunately happening with COVID as well. So but yeah, this is a different use case altogether. So here, implementation benefit to the hospital. um, so what happens is, if suppose you are um, getting admitted to the hospital for a hand injury, the reimbursement at the final documentation and the final payment, what you would be getting from the insurance company is basically only for the hand injury only. And if suppose during your stay sepsis is developed, um, in that case the hospital loses its reputation. The hospital, the overall patient stay would increase. Hospital would have to treat the patient for the infection uh, with their own cost. I mean, there will be no sort of reimbursement happening uh, to the patient, or maybe to the hospital from the provider. So that is, I mean, um, this is the business scenario of why hospitals are very eager to develop this um, AI mechanism, or like early detection of sepsis model into their hospitals. So uh, yeah, I hope you guys have able to understand the use case. I'm not talking technical at all here. Everyone now, I mean, everyone understands, everyone goes to hospital, or like has been to hospital for a certain diagnosis or condition, and how exactly, where exactly sepsis, where exactly machine learning in sepsis is coming into place. This is very important to understand. So any questions, or maybe any silly doubt or something, I'm happy to answer. All right. Nothing. All good. Okay. All right then. Let's move forward. Advantages of a sepsis model. So, I mean, just let's go point wise. So, sepsis model, like it can assist clinicians in detecting patients likely to become septic and near septic in the near future, enabling them to intervene before the condition has chance to progress. Early prediction of sepsis is crucial in preventing mortality, given that sepsis management is highly time sensitive. So, so sepsis, again, like patient moves into sepsis, and many times the operations, the hospital management, the floor staff, the clinician do not get to know about if a patient has moved into sepsis shock, and like higher rate of I mean, very close to death, or maybe very close to an emergency situation. So that is where early prediction of sepsis becomes very crucial. Isolate and take better care of patients who are likely to develop sepsis. Early prediction of sepsis can help in reducing the length of stay of a patient. That is, this is what I have tried to tell in the previous slide as well. So, and the last point, last but not the least, I would say, hospitals do not get reimbursed for infection which is developed during the patient's stay and not captured
Anything?
as, yeah.
Yes. Yeah. As so I have actually ideas. So could I use a model? Could I build a model like implement in a app so that we could actually predict that a patient is going to be infected by corona or like something in this time? Could we
Yeah,
build a
so
model and implement in a application so that it will ask some inputs from the from a like from a user, and we could predict that he is prone to infection or something like that?
okay, yeah, I understand what's going on in your mind, and thanks for putting this across as a question. But the problem I see here is the capture of data at a very timely interval. That won't happen in case of COVID, or maybe it's difficult to happen in case of COVID. So if at all the situation is such that I mean, you can definitely do it when a patient is inside the hospital. You are treating a patient for a certain disease, and also monitoring COVID related symptoms as well. And that's the same scenario happening for sepsis also. Um, Here in sepsis, they look at some lab results, or they kind of look at, again, they look at, I have that in the coming slides, what kind of variables they look at. In COVID also, it would be the same scenario, but there are very less, or maybe very minute cases where a patient is coming to the hospital for a different disease and is actually getting infected by COVID. I mean, that is not the scenario as on date. The scenario is much worse. COVID is happening in resident. I mean, like you know what the scenario is, right? So um, this particular model of sepsis is more pertaining to critical care unit inside hospital itself, or maybe emergency unit inside hospital itself, whereas COVID has, I mean, the effect of COVID is much worse. So if we are trying to restrict COVID in terms of just inside hospital only, in that case, definitely there can be a work around it. And it would be a very similar problem wherein you are going for a hand injury or leg injury, and meanwhile there is a symptom being diagnosed, or maybe there is some sort of an early intervention that the person is moving into COVID. So but right now that is not the case. You might even not have the training data for it.
Yeah, cool.
So I think one app called Arogya Setu by Government of India is also tracking this kind of for COVID. Using the Bluetooth connections and other, they try to predict how many person I have interacted and how many of them are actually getting infected. In this way, they are trying to predict.
No, okay. How much I know, Arogya Setu, what they are doing is basically they are based on your geographical location, based on your consent to give out location, they are able to track who are the near about people in your location who have COVID. So their feature is nothing but just one feature of distance proximity. So zip code, or maybe not zip code, but point A to point B, what is the distance, and based on that they are trying to give out that are you coming from so and so zone or no. So that is the only metric. So proximity is the only metrics what they are using.
Could we identify the kind of the properties of a human, so that we could like warn that particular person you will be like more likely to be infected by corona or something? If we could find out those factors,
See,
maybe it might be the blood.
the thing is, I mean, because this is it's not something been happening since quite some time. You do not have the data for it, and you do not have like enough data. So there is no question of, or maybe there is very less chances of machine learning and AI coming into picture here. Okay, here the work is more statistical based only. So like, for example, I have done some analysis where how remdesivir, like just testing on 1,000 patients, how remdesivir can be is statistically significant for COVID related patients, or maybe how heparin, like a different um, medication is good, or maybe statistically significant for COVID patients, or maybe say patients taking spirometry test. I'm not sure if you have heard of it, but spirometry test is that like you have a, a ball like thing at the bottom, you take deep breath and the ball comes up. So taking spirometry tests at significant intervals is helping COVID patients or no. So that is more of research and statistics coming into place because you don't have a lot of data for it. So that's a you right now we are in a situation where we can only try to understand things more effect from a particular variable and statistics driven sort of a thing. ML and AI, I mean ML, like it would come into place where you kind of have, like for example for sepsis, I mean this is a well known or well researched disease altogether, where you understand that a patient is actually likely to get sepsis, and you already have significant data for it. So and also this is all been happening inside the EHR only. It's not like happening um, at a resident or something. So yeah, I hope I have kind of like tried to answer your question of how dealing with like deep learning or any other ML techniques for a corona related problem is difficult.
Yeah, got it.
Yeah. Any other questions? Anyone on similar lines? Okay. All right. Let's move ahead. Okay. So model workflow for sepsis. So now we are like getting a little technical, I would say, where we are trying to understand how exactly sepsis workflow works. What are the kind of parameters or data which comes into place, and how this can be utilized for detection of sepsis. So EHR, I mean, you call it EHR or you call it EMR. Structured data. So structured data is in the form of vitals, labs, treatments, medications, all the other diagnostic conditions, those things. These are all in the form of structured data. Unstructured data are in the form of notes. So as you understand that how NLP is important. So admission notes, progress notes, pharmacy notes, all these other different note types. So you take into consideration all of these things together. Then you put this, I mean, then you have your trained model. I mean, this is something we are talking about at the production level. So you have your trained model, and whether a sepsis is diagnosed, yes or no. If no, then there is again that particular patient, basically that particular encounter of a patient is actually going into like a T+4H. So that specific time plus 4 hours, or that specific time plus 6 hours. So whatever the management decides, it depends on which unit are we talking about. Like, is it an emergency room, or is it an ICU unit, or things like that. And accordingly they take a decision when the model has to be rerun. The model reruns based on all these latest factors again being captured, and based on that the model again reruns, and accordingly like the same process happens of identifying whether it's a sepsis or no. So to train this model of sepsis, I'm not going into that detail, the technical details of it, like training the model of sepsis, what sort of algorithm is used. but here it's more about the case study, more about the use case, where how it can be utilized for the operations inside the hospital for to better care patients, and also the monetary benefit of it to the hospitals. So more on these lines. Okay. All right. Any questions? We can move ahead maybe. So so now we on the left hand side. So there are basically two different pictures out here. The left hand side is about the timing. What sort of timing is important? So as mentioned in the previous slide, like T+4, T+6, how exactly you try to understand where to run the model, or where to like till what level do you capture the features, and from there till what level you want to try to understand the prediction. So or maybe you even try to make it dynamic, or you just try to make it on the basis of like if suppose I enter into the hospital and just after 6 hours run a model on me based on all my recent vitals, recent labs, and all these factors, and try to understand whether there is a sepsis or no. So that is one way of doing it. The other way of doing it is I enter into the hospital, and at the moment where there is a certain flag happening, like a certain flag, basically if there is an order given by the physician for a certain lab test, so that's basically coming from the physician that okay, kind of go ahead and test for so and so lab. So in that case there is a trigger happening that okay, if this lab is being ordered by the physician, then something is suspicious, go and test for sepsis as well. So 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 running of this model in real time is a very complex task. It's not that easy. And whether you want to do it at a fixed timestamp interval, or want to do it in terms of like a rule based specific order being done, or maybe specific medication being given, that also becomes suspicious. So things something like that. And on the right hand side, and again, like just to kind of understand it very in a way you want to relate and understand, then you can definitely relate this with COVID as well. It's kind of a similar situation wherein you want to do a repetitive test at a certain interval, or you want to do a test when like a certain medication is administered. So things like that. And yeah, it's your own call, or maybe it's the management call when to take when to kind of run this model and how to run this model. So and on the right hand side we see the different different features out there. So vitals, demography, labs, arterial blood gas, and observations. So and this again depends on system to system and hospital to hospital. So it can increase, or maybe if they want to go with even more finite and crispier list, then they might decrease. But yeah, certain parameters are always important. So I guess with this I have ended the use case for sepsis. So any questions so far?
I still have the doubt about the left figure, that left alignment and right alignment. Can you just explain in the context?
Yeah, sure. So so this left alignment and right alignment is, so left alignment, what it says is basically you start off with patient at the time of, with the prediction at the time of admission for a certain timestamp, and like you have a fixed length of timestamp, say 6 hours or something, and 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 then that particular predictive model, it kind of repeats at every 2 hour or every 3 hour after a patient is um, patient after a patient is admitted into the hospital. The other way to look at it is more of like, it depends on any order or any sort of like any medication given to a patient, or any like any order for a lab given to a patient, or any fluctuation in vitals happening to the patient. So in that case, you have this prediction window, wherein in that period you can predict and try to assess whether there is a sepsis or no. So there are like two ways, two different ways, or maybe there could be even more ways to look at this problem of how exactly, at what time exactly are we trying to predict. I mean, uh, the goal here is to do an early prediction, and that early prediction is very much early enough, um, decreasing the false positives as well, and is also an indicator, like you kind of want to isolate the patient or maybe take good care about the patient. You don't want to predict when the disease has already happened. And I mean, maybe you don't want to do it like a very much rule based sort of a thing. Like, for example, uh, to give you an example of COVID, you would not want to predict when already the oxygen is below 80 or something, right? You want to predict it at somewhere around when a patient is well around 90, 85, 90 itself, with most of the other parameters still being stable. You still want to predict then itself, but you don't want to predict at a very later stage. So there are two ways to do it. Either you do it at every 2 hours, every 1 hour, every 2 hour, or you kind of try to do it in a way that um, like certain medication is, maybe a dolo 650 is given, okay, then let's try to do it then, because a physician has ordered for a dolo 650, then something is wrong, maybe the temperature level is increasing. So then you try to predict. So both ways actually, and this is what is being tried to tell here in this left alignment and right alignment as well.
So why would
Okay,
we like
then
to go with
we'll
the
explore
second
predict.
model? Like, why would we like to go with the second model when we want that our disease gets like identified quite early? Like, if it is better that we do it in a periodic manner, why do it the second way?
That is basically to reduce the false positives, because if you're doing it at a very much periodic sort of a way, in that case there is no in that case there might be a situation of lot of false positives happening. You do not want to predict sepsis when a patient would ideally not fall in sepsis at all. So that is something you would not want uh, to happen for, because of your model. So there has to be some sort of surety out there. So in that case, you don't want to do it at some regular timestamp or something, but more of try to run your model when a certain actionable insight is actually taken by a physician. So that is, it's more of to reduce false positives actually.
And what about the first one?
The first one is more of periodic. I mean, you kind of do it at a very periodic level.
I mean, the use case, like as you explained in case of second model, like we want to reduce the false positive. What's the objective behind the first model?
See, there is, I mean, it's not that there is an objective, there is a fine objective behind it. It depends on, as I said, like it depends on the institute, on the management, or maybe like whoever you're working with as a data scientist, like your chief medical director or whoever, CMO, whoever it is, if they want to do it at a regular 2-hour timestamp interval, for suppose an emergency unit or something, then maybe they go ahead and do that. Or, and if they do not want it in such a way, they want it in a different way, wherein only if a diagnostic, if something is administered, only then they do. So in that case, it is not timestamp based, but more of evidence based, right? So here, the previous slide which I have here, this says it's just been done T+4, T+6, T+12, T+24, and T+48. So they are doing it every 4 hour, every 6 hour, every 12, every day, and every 2 days. So they are trying to do it in that way, right? So there are
Yeah.
so what basically I'm trying to tell here is that this is not a model wherein like you build and you deploy and that's it, everyone goes crazy about it. But here it is the timing, the real-time implementation, those things are very much important for it to excel. I mean, irrespective of what algorithm you're using, it's very much needed to analyze how exactly you go about in any sort of healthcare related problems.
Yeah, cool.
Okay, one another question. So yeah, as we are like predicting every 2 hours, like it's very much complex to collect every 2 hours data, isn't it?
No, it's not complex. It's definitely not complex to collect data in 2 hours, because that's something happening from the EMR, right? Like you have your model built and you are setting up the pipeline. So you just pick the latest records, latest vitals, latest lab results, and all the latest data, updated data, what you have. So every 2 hour or every 3 hour, that's not difficult. That's something very much manageable.
Okay, cool.
Okay, all right. So okay then, all right. So I'll just kind of go through very briefly about prediction of length of stay in a hospital. I guess we still have some time, right? We have around 15 minutes or 10 minutes or something.
Yeah, we have 15 minutes.
Okay, so yeah, let's do this very quickly. So prediction of length of stay in a hospital. So length of stay in a hospital, basically how many days are you staying inside the hospital, right? So length of stay is defined as the time between the hospital admission and the discharge, measured in days, or you measure it in whatever scale you want to. But in general, length of stay is measured in days. So problem statement here is the goal of this project is to create a model that predicts length of stay for each patient at the time of admission. So here you're trying to predict just at the, I mean, not like at the time of admission itself. I mean, you would not have any features to capture there, but yeah, at like certain time after the admission has happened, you try to predict the length of stay. And then you actually are end goal here is to compare the predicted length of stay with geometric length of stay. So what is geometric length of stay? This is a standard LOS metric set by CMS. And what is a CMS? CMS is the governance body which actually handles all the US hospitals together. Like maybe India, I think it's NRC, no, not ICMR. I think ICMR handles most of these things, but so in US healthcare, it is CMS. Okay, so all right, so what is GMLOS? So GMLOS, standard LOS metric to set by the hospital. So all right, so let me, okay. All right, so if you see this this slide, this is an exploratory analysis of prediction of length of stay. So again, sepsis word is used here again. So sepsis GMLOS is 4.8 days. Heart failure GMLOS is 4 days. So what does this mean? 4.8 days and 4 days. What it means is, suppose if a patient is coming in for a heart failure related specific ICD-10 code. So in that case, he or she will be in the hospital for just 4 days and not more than that. So if a patient is staying for more than 4 days or something with no proper medical evidence, so in that case, the reimbursement will not be provided to the hospital and the hospital will have to bear the expenses by themselves. So it is not that what happens, I mean, what we have heard many times or maybe would have experienced also, that hospitals are, I mean, deliberately making the patient stay for a longer time to kind of like escalate the bill or something, right? So that is not something in the case of US healthcare, wherein they have a fixed diagnosis and for that fixed number of days for a diagnosis. And if a patient is staying for more days, then you will have to practically give out evidences to your to the insurance companies, and only then they will reimburse. So this is the problem statement here, where how an early prediction will actually help for a specific patient if the number of days is like pretty much higher than the geometric length of stay. In that case, they would maybe give more attention to that patient, or maybe there is like there may be certain way that they would just increase, they would just change the diagnosis code itself to a higher geometric length of stay, right? So I hope I'm clear what I've just spoken about prediction of length of stay. So
Nitin, hello.
Yeah.
So one more doubt. So here we are considering the geometrical mean. So it's not a kind of symmetrical curve at all. So I think median would be a better choice instead of mean.
No, this is not mean. This is geometric mean, wherein this is like a geometric mean length of stay calculation is not like it's not actually the average, but a geometric average of it, which is again a different calculation altogether. Maybe you can check for geometric mean calculation. You can Google that. This is not mean here. And I understand what you're trying to say, that we can take
geometrical mean. Geometrical mean is essentially it's the like it's kind of multiplication and then the root over of the whole
right. It's a different calculation altogether, and it's not the average or mean.
Thank you.
Okay. All right, so now we have like understood what the problem is. Sepsis, heart failure. So just to again try to tell you that, okay, if suppose I've gone for a hand fracture or something, and as per the ICD-10 code, what diagnosis it is, I'm supposed to stay for 3 days in the hospital, and the hospital has to treat me under 3 days and discharge me, right? So if there is a model being run on my diagnoses, my symptoms, my lab results, my all other conditions, and if suppose the length of stay is coming to somewhere around 7 days or 8 days, so definitely there is a lot more complexity in my case, and it is not just a simple hand injury which is leading to 3 days geometric mean length of stay. So there is definitely an opportunity for the hospital to relook at my case and get a better understanding about my profile. Otherwise, they might just end up treating me for 7 days or so, but will only get reimbursement for 3 days, which is ideally a loss to the hospital. All right, so features, vitals, utilization, labs. All right, so this is some exploratory analysis. We're talking about the hospital. Again, you can see the spread of length of stay, comparison of ethnicity, and this is just like how you guys do exploratory analysis on all the features with respect to length of stay. So very similar insights. So okay. All right, so these are the modeling results. Okay, all right. I think I have briefly covered length of stay, and I have also covered sepsis as well. By the way, length of stay modeling is a regression-based problem, wherein if you see here, we are trying to understand what will be the predicted length of stay, and accordingly, like you're trying to assess the RMSE results, and trying to understand what exactly would be the how exactly is your model in total, the model assessment in total. Okay. All right, so with this, I think I have come to an end of this case study, data science case study of healthcare in machine learning. I hope you guys have got some idea of how in real world healthcare AI is working in the current scenario. Any questions, or we can go ahead and end this session. We are good. I think
Can you cite some other use cases in healthcare?
other use cases, quite a few. So let me go back to my slides itself. So these are the other use cases like computer vision, NLP. You have readmission of a patient, wherein you try to, so again, in US healthcare, if a patient is getting readmitted within 30 days from the time he's discharged, there is a penalty given to the hospital. So you obviously want to predict whether a patient will be readmitted or no. So something like that. That's also a use case. And early prediction of sepsis. There can be early prediction of heart failure or many other complex diseases. There is a lot going on with respect to denials. Like what happens is hospitals, they bill for a patient and there is a denial happening. So how do you deal with that? Early prediction, I mean, like predicting whether a particular claim, this is more about hospital billing and finance. So predicting whether a claim will actually get denied, that is also a use case. And again, imaging altogether is a different ball game altogether, I would say, where you have a lot of radiologies, cancer detection problem, and brain tumor related is also, I mean, they are also using a lot of these latest technologies or advancements in computer vision. Yeah.
Yep.
Okay. All right. Any other questions? Okay, then. All right. Thank you, everyone. Thanks.